Every jet aircraft you've ever flown on, every commercial airliner crossing the Atlantic, every military fighter screaming through the skies, they all share one thing in common. They're powered by an invention that came from the mind of a single British officer in 1930. His name was Frank Whittle. He was just 22 years old, fresh out of flight school, when he sat down and designed the jet engine. Not a prototype, not a sketch. A complete, workable design that would revolutionize aviation forever. He took his invention to the people who should have been celebrating him. The British Air Ministry, the government, the experts, and they told him no. Not just no, they told him his idea was impossible, that the materials couldn't handle it, that it would never work. They refused to give him a single penny. But here's where it gets worse. Whittle didn't give up. He spent his own money, scraped together funds from friends, and filed a patent in January 1930 to protect his invention. For 5 years, he fought to keep that patent alive. And in 1935, when it came time to renew it, he needed just £5. 5. That's all it would have cost the British government to keep the jet engine a British secret. They refused. The patent expired. And the moment it did, it became public property. Anyone in the world could read it, study it, copy it. And someone did. The Germans got their hands on Whittle's patent, and what they did with it would change the course of the Second World War. This is the story of how Britain invented the future and then handed it to their enemies. How one man's genius was ignored, dismissed, and ultimately stolen. And how the country that should have led the world in jet aviation ended up watching from the sidelines as others took the glory. Frank Whittle gave everything to his invention, and his country gave him nothing but betrayal. He wasn't born into privilege. There were no family connections to the Air Ministry, no old money estates, no doors that opened because of his surname. Frank Whittle was the son of a mechanic from Coventry, a working-class kid who grew up covered in engine grease, watching his father fix machines in a small workshop. That's where he learned to think with his hands, to see problems not as abstract puzzles, but as things you could take apart, rebuild, and make better. When he applied to join the Royal Air Force in 1923, they rejected him. Not because he wasn't smart enough, not because he lacked ambition, but because he was too short, 5'2", below the minimum height requirement. Most people would have walked away. Whittle went home, spent 6 months doing physical exercises to stretch his frame, ate like his life depended on it, and came back. This time, they let him in. He arrived at RAF Cranwell, the service's officer training college, in 1926. And he didn't just survive, he thrived. By the time he graduated in 1928, he was second in his class. Not bad for a mechanic's son who wasn't supposed to be there in the first place. But it was what happened during those years at Cranwell that would change everything. In 1928 and 29, Whittle wrote a thesis on high-speed flight at high altitudes. It wasn't some theoretical exercise to impress his instructors. It was a practical problem he was trying to solve. Aircraft of the time were slow, inefficient, limited by the drag of thick air at low altitudes. Whittle saw that if you could fly higher, where the air was thinner, you could go faster with less resistance. The problem was simple. Propellers don't work in thin air. They need dense atmosphere to bite into, to generate thrust. The higher you go, the less effective they become. So Whittle asked himself a question. What if you didn't need a propeller at all? What if you could design an engine that worked by pure jet propulsion, sucking in air at the front, compressing it, burning fuel, and blasting it out the back at tremendous speed? An engine that would actually get more efficient at high altitude, not less. It wasn't a fantasy, it was engineering. And in 1929, Frank Whittle put the entire concept down on paper, complete with calculations, diagrams, and specifications. He was 22 years old. He did what any young officer with a revolutionary idea would do. He sent it up the chain of command. In 1929, Whittle submitted his jet engine concept to the Air Ministry, the government department responsible for Britain's air power. He wasn't asking for millions. He was asking them to look at it, to consider the possibilities, to recognize that this could change aviation forever. The Air Ministry called him in for a meeting. They wanted him to present his idea to an expert, someone who could evaluate whether it had any merit. That expert was a man named A. Griffith, a senior engineer at the Royal Aircraft Establishment. Griffith was brilliant, respected, and deeply involved in research on gas turbines. On paper, he was the perfect person to assess Whittle's work. But there was a problem. Griffith had been working on his own turbine designs for years. Not jet engines, but turbines designed to drive propellers more efficiently. Whittle's concept, if it worked, would make Griffith's entire approach obsolete. So when Whittle stood in front of him and explained his idea, Griffith didn't see a breakthrough. He saw competition. He picked through Whittle's calculations, found what he claimed were errors, and dismissed the whole thing. Impractical, unworkable, not worth pursuing. The Air Ministry sent Whittle a letter. It was polite, formal, and devastating. They informed him that current materials could not withstand the temperatures and stresses his engine would generate, that his idea, while interesting in theory, had no practical application. They would not be funding further development. Most people would have stopped there. The British government had spoken. The experts had ruled. It was over. But Whittle wasn't most people. If the Air Ministry wouldn't protect his invention, he would do it himself. In January 1930, he filed a patent for his jet engine design. It cost him money he didn't have, but he did it anyway. And then the Air Ministry made a decision that would haunt Britain for decades. They had the power to classify Whittle's patent, to keep it secret, to prevent it from being published in technical journals where anyone could read it. After all, if this was a potential military technology, even a long-shot one, shouldn't it be protected? But they didn't see it that way. In their view, the jet engine had no military value, so they let the patent go through the normal process. It was published in 1932, printed in engineering journals, catalogued in libraries, available to anyone in the world who cared to look, including Germany. The patent specifications, complete with Whittle's calculations and diagrams, were now sitting in technical libraries across Europe. German engineers could study every detail, see exactly how the jet engine worked, and use that knowledge however they pleased. Britain had just handed its greatest aviation secret to the world, free of charge, and Whittle could do absolutely nothing about it. What followed were 5 years in the wilderness, 5 years of rejection, frustration, and watching his invention gather dust while the world moved on without him. From 1930 to 1935, Frank Whittle became a man obsessed. He continued serving in the RAF as a test pilot and flight instructor, but every spare moment was spent trying to find someone, anyone, who would take his jet engine seriously. He went door to door, figuratively speaking, pitching his idea to anyone who might listen. Engineering firms, aviation companies, investors. Most of them looked at his designs, nodded politely, and showed him out. A few were genuinely interested. British Thomson Houston, one of the country's largest electrical engineering firms, actually sat down with him and studied the concept in detail. They could see the potential. They understood what it could mean. But when it came time to commit, they walked away. Building a working prototype would cost around £60,000, they said. That was too much, too risky, too uncertain. So they thanked Whittle for his time and sent him on his way. Whittle kept going. He had no choice. This wasn't just an invention to him, it was his life's work, the thing he believed in more than anything else. He continued refining his designs, running calculations, trying to prove to the doubters that this could be done. But as the years dragged on, the weight of it all began to crush him. And then came January 1935. That was when Whittle received a notice from the Patent Office. His patent, the one he'd filed 5 years earlier, was up for renewal. The cost to keep it active for another year was £5. Just 5. In today's money, that's barely £100. A trivial sum for a government department. A rounding error in a ministry budget. But for Whittle, it might as well have been $5,000. He was an RAF officer on a modest salary. He'd already spent everything he could spare on filing the original patent, on traveling to meetings, on materials for his designs. He didn't have £5 to spare, so he did the only thing he could think of. He wrote to the Air Ministry and asked if they would cover the renewal fee. After all, this was a British invention, a potential military technology. Surely, even if they didn't believe in it, they could see the value in keeping it protected. Surely £5 was a small price to pay to prevent other countries from copying it freely. The Air Ministry said no. They didn't offer an explanation. They didn't suggest an alternative. They simply refused. And so, in January 1935, Frank Whittle's patent expired. The moment it did, his jet engine design became public domain. Anyone in the world could now use it, build it, profit from it, without paying Whittle a single penny or acknowledging his work in any way. Years later, Whittle would say he was ready to give up, that he'd reached the point where continuing felt impossible. 5 years of rejection. 5 years of watching bureaucrats and executives dismiss his work. And now, the one legal protection he had was gone, because his own government wouldn't spend £5 to keep it alive. But just when it seemed like the story was over, something unexpected happened. While Whittle was struggling in Britain, unable to afford £5 to protect his work, something was happening 1,500 kilometers away in Germany. Something that would prove just how catastrophic the Air Ministry's decision had been. In 1932, when Whittle's patent was published in technical journals, copies made their way into libraries and research institutions across Europe. One of those copies ended up at the University of Göttingen, in the hands of a young physics student named Hans von Ohain. Von Ohain was brilliant, ambitious, and fascinated by the idea of jet propulsion. And now, thanks to the British government's refusal to classify Whittle's patent, he had a complete blueprint sitting right in front of him. Von Ohain would later admit, openly and without hesitation, that he read Whittle's patent. His own patent lawyer gave it to him, he studied it, he critiqued it, and then he used that knowledge to design his own jet engine. Years later, von Ohain said, "We had to narrow our patent claims compared to Whittle, because Whittle had shown certain things." That's not an accusation. That's a confession. Whittle had laid out the fundamentals, and von Ohain built on them. But here's where the contrast becomes almost unbearable. When von Ohain took his jet engine concept to the German aviation authorities, they didn't dismiss him. They didn't tell him it was impractical. They didn't refuse to fund it. Instead, they connected him with Ernst Heinkel, one of Germany's leading aircraft manufacturers. Heinkel looked at von Ohain's work and gave him everything he needed. unlimited funding, a dedicated team of engineers, access to the best materials and facilities in Germany. Whatever it took to make the jet engine a reality, Heinkel was willing to provide. Frank Whittle couldn't get £5 from his own government. Hans von Ohain got a blank check from his... And while Whittle spent 5 years knocking on doors and getting turned away, von Ohain spent those same years in a fully equipped laboratory, building prototype after prototype, moving steadily towards a working engine. By 1935, the same year Whittle's patent expired, von Ohain was already running bench tests on his first turbine designs at Heinkel's facilities in Rostock. He had machinists, metallurgists, aerodynamicists all working under him. He had wind tunnels, testing rigs, everything a cutting-edge research program could want. The British had invented the jet. The Germans were going to perfect it. And it was all because one side believed in the future, and the other couldn't be bothered to protect it. The irony was staggering. Whittle had done the hard part, the creative leap that required true genius. Von Ohain had the easier job, taking an existing concept and engineering it into reality. But von Ohain had something Whittle didn't: support, resources, a government that understood what was at stake. Britain had handed Germany the keys to the future of aviation, and now they were about to pay the price. The German jet program was accelerating, backed by industrial might and military urgency. Whittle, meanwhile, was still flying training missions for the RAF, his revolutionary engine gathering dust in patent offices, his dreams seemingly finished. 2 men, 2 countries, the same invention. But only one of them was moving forward. But in May 1935, just as everything seemed lost, someone decided Frank Whittle deserved a second chance. That someone was Rolf Dudley Williams, an old friend from Whittle's days at Cranwell. Williams had followed Whittle's struggles from a distance, watched him get rejected again and again, and finally decided enough was enough. He contacted Whittle and said something that changed everything. "I have a plan. We'll find private money." Williams wasn't an engineer. He was a businessman, someone who understood how to put deals together, how to find investors willing to take risks. And he believed in Whittle's vision enough to stake his own reputation on it. He brought in another partner, James Tinling, and together the 3 of them founded a company in March 1936. They called it Power Jets Limited. Their total budget was £2,000. That's it. £2,000 to build an engine that would revolutionize aviation. To put that in perspective, Hans von Ohain at Heinkel had access to millions of Reichsmarks, an entire industrial complex, and teams of specialist engineers. Whittle had a shoestring budget and 2 business partners who believed in him, but it was more than he'd ever had before. They scraped together what they could, rented space at the British Thomson Houston Works in Rugby, and got to work. Whittle designed every component himself, supervised the machining, assembled the parts by hand. It took nearly a year, but by April 1937, they had something that looked like it might actually work. A prototype jet engine, crude by modern standards, but revolutionary for its time. April 12, 1937. That was the day they fired it up for the first time. The test took place at the British Thomson Houston factory in Rugby. Whittle stood in front of his engine, a tangle of metal tubes, compressor blades, and combustion chambers, all held together with more hope than certainty. A small crowd had gathered, engineers from the factory, his partners, a few observers who'd heard rumors about what Whittle was attempting. Everyone was nervous. No one knew if this would work, or if it would tear itself apart the moment they started it. Whittle opened the fuel valve. The engine ignited with a roar that sounded like an air raid siren. High-pitched, screaming, echoing off the factory walls. The compressor blades spun faster and faster, the turbine howling as it sucked in air and blasted it out the back. Whittle watched the tachometer climb. 2,000 revolutions per minute. 4,000. 6,000. The noise was deafening. And then he tried to shut it down. He closed the fuel valve. The engine should have stopped. It didn't. The turbine kept spinning, kept screaming, faster and faster. 7,000 revolutions per minute. 8,000. The metal casing began to glow, dull red spots appearing on the surface as the temperature inside climbed beyond anything the materials were designed to handle. People started backing away, then running. Engineers scattered, ducking behind equipment, putting as much distance as they could between themselves and the engine that was now completely out of control. Whittle stood there, frozen. He couldn't move. He'd spent 7 years of his life on this machine, and now it was about to explode in front of him. But it didn't explode. The fuel finally burned through. The turbine lost power, and the screaming began to die down. The engine coasted to a stop, ticking and creaking as the metal cooled. Whittle stood there, shaking, staring at the machine that had just refused to obey him. Years later, his son Ian would recall what his father told him about that moment. Whittle had thought to himself, "My God, I've invented a perpetual motion machine." It wasn't perpetual motion, of course. It was just a fuel valve that hadn't sealed properly, allowing residual fuel to keep the combustion going even after Whittle thought he'd shut it off. But in that terrifying, exhilarating moment, Frank Whittle proved something that the Air Ministry, the experts, and all the doubters had said was impossible. The jet engine worked. The test wasn't perfect. Far from it. The engine vibrated violently, ran hotter than it should have, and nearly destroyed itself in the process. But it ran. It produced thrust. It proved the concept was sound. Over the next 2 years, Whittle and his tiny team at Power Jets refined the design, fixed the fuel system, improved the combustion chamber, strengthened the turbine blades. Each test brought them closer to a production-ready engine. By 1939, they had a working model designated the W1, capable of sustained operation without trying to shake itself to pieces. It was ready to be installed in an actual aircraft. But while Whittle was inching forward on a shoestring budget in Rugby, von Ohain was sprinting ahead in Germany with unlimited resources. And the race was about to reach its finish line. August 27, 1939. A small experimental aircraft took off from Rostock-Mariannhill airfield in Germany. It was called the Heinkel He 178, and it was powered by Hans von Ohain's jet engine. The flight lasted just 6 minutes, a brief hop around the airfield, but it was enough. Germany had just achieved the first jet-powered flight in history. The engine worked, the concept was proven, and the world had changed. Britain, meanwhile, was still 2 years away from its first jet flight. On May 15, 1941, a strange-looking aircraft called the Gloster E-28/39 lifted off from RAF Cranwell, the same place where Frank Whittle had first dreamed up the jet engine 12 years earlier. It was powered by Whittle's W1 engine, and it flew beautifully. Smooth, stable, faster than any propeller-driven aircraft of its size. But it was too late. Germany had already won the race. They'd beaten Britain by nearly 2 years, using knowledge that had come directly from Whittle's own patent. Whittle would later say, with barely concealed bitterness, "If they had listened to me, we would have been 6 years ahead of the Germans." And he wasn't exaggerating. Von Ohain himself confirmed it. Years after the war, When the two men finally met and became friends, von Ohain admitted, "If Whittle had been given the money, you would have been 6 years ahead of us. Perhaps the Second World War would not have happened." Think about that for a moment. 6 years ahead. If the Air Ministry had funded Whittle in 1930 instead of dismissing him, Britain could have had operational jet fighters by 1936, before the Messerschmitt Bf-109, before the Spitfire, before the war even started. The entire balance of air power in Europe would have been different. Germany might never have felt confident enough to launch a war in the first place. But that's not what happened. Instead, Britain and Germany spent the next few years locked in a desperate race to turn experimental jets into combat-ready fighters. And once again, Germany had the advantage. By July 1944, the Messerschmitt Me 262 entered service with the Luftwaffe. It was the world's first operational jet fighter, capable of 540 miles per hour, faster than anything the Allies had in the sky. It could outrun Spitfires, Mustangs, everything. Britain's answer was the Gloster Meteor, powered by an improved version of Whittle's engine. It entered service that same month, July 1944, almost simultaneously, but the Meteor was slower, 490 miles per hour at best, 50 miles per hour slower than the Me 262. Not a huge gap, but enough to matter in combat. And here's the final, bitter irony. The Meteor never fought the Me 262. Not once. The RAF kept the Meteor in Britain, using it to intercept German V-1 flying bombs over the English countryside. They didn't trust it enough to send it into combat over Europe, didn't want to risk one being shot down and captured by the Germans. So the world's two operational jet fighters, born from the same British invention, never met in battle. Whittle had created the future. Germany had seized it. And Britain, the country that should have led the world into the jet age, was left playing catch-up with its own technology. Germany produced over 1,400 Me 262s before the war ended. Britain built fewer than 300 Meteors, and most of those never left British airspace. The technology gap was stark, the production gap even more so. And Whittle, watching all of this unfold from his workshop at Power Jets, knew exactly why it had happened. His country had refused to believe in him when it mattered, and now they were paying the price. The Me 262 terrorized Allied bomber formations over Germany, shooting down hundreds of aircraft with its superior speed and firepower. Pilots reported seeing these sleek, swept-wing fighters appear out of nowhere, make a single devastating pass, and vanish before anyone could react. Meanwhile, the Meteor sat on British soil, swatting V-1 rockets out of the sky, a job any good Spitfire could have done. Whittle's engine had been designed to dominate the skies over Europe. Instead, it was being used for home defense, while German jets, built on his ideas, ruled the air. But the worst betrayal was still to come. In 1943, with the war still raging and Whittle's jet engine finally proving its worth, the British government made a decision. Power Jets, the company Whittle had built from nothing, the company that had survived on 2,000 pounds and sheer determination, was too important to remain in private hands. Winston Churchill's administration nationalized it, took it over completely, turned it into a state-controlled enterprise. The shareholders received compensation, £135,500, split among the investors who'd backed Whittle when no one else would. Rolfe Dudley Williams, James Tinling, the others who'd believed in the project, they all got paid. Frank Whittle got nothing. As an officer in the Royal Air Force, he was legally required to surrender his shares to the Air Ministry. No compensation, no buyout, nothing. The company he'd founded, the engine he'd designed, the patents he'd filed with his own money, all of it was now property of the Crown. The same government that had refused to give him £5 to protect his patent in 1935 now owned everything he'd created. But they weren't finished with him yet. The government immediately transferred Whittle's patents to British manufacturers. Rolls-Royce, Bristol, de Havilland, they all received complete access to his designs, his calculations, 15 years of research and development, handed over for free. These companies would go on to build jet engines worth billions, entire product lines based on Whittle's work. They paid him nothing, not a royalty, not a licensing fee, nothing. Whittle kept working, kept pushing himself, trying to maintain some control over the technology he'd created. But the pressure was crushing him. He was working 18-hour days, supervising engine tests, consulting with manufacturers who'd once ignored him and now treated his inventions as their own property. The stress, the exhaustion, the sheer injustice of it all, it was too much. March 1944. Frank Whittle suffered a complete nervous breakdown. He was hospitalized for 6 months. The doctors said it was severe exhaustion combined with acute anxiety. His body had simply given up. For half a year, the man who'd revolutionized aviation couldn't get out of bed, couldn't work, couldn't function. And while he was lying in a hospital ward, Rolls-Royce was ramping up production of the Welland engine, a direct derivative of Whittle's W2 design, preparing to power the Gloster Meteor into combat. When Whittle finally recovered enough to return to work, he found that power jets no longer existed, not in any meaningful sense. The company had been restructured into Power Jets Research and Development Limited, a government entity focused on experimental work. Actual production, the profitable part, had been stripped away and given to Rolls-Royce. Whittle's team, the engineers who'd stood by him through the worst years, were scattered. Some transferred to Rolls-Royce, others left the industry entirely. Whittle himself was sidelined. He held a title, a position on paper, but no real authority. The decisions were being made elsewhere by people who'd contributed nothing to the invention but now controlled its future. In 1946, he resigned, walked away from power jets in protest. He remained in the RAF, promoted to Air Commodore, given honors and recognition, but his role in jet engine development was finished. The Air Ministry had taken everything he'd built and handed it to corporations who'd refused to risk a penny when it mattered. But while Britain was taking everything from Whittle, America was getting ready to take even more. In October 1941, General Henry Hap Arnold of the United States Army Air Forces made a request to the British government. He wanted access to Whittle's jet engine technology. Britain, desperate for American support in the war, agreed immediately. They shipped one of Whittle's W1X engines across the Atlantic, along with complete blueprints for the improved W2B model. Everything, every calculation, every specification, every hard-won innovation that Whittle had developed over 12 years of struggle. The engine and the plans went to General Electric, one of America's largest industrial corporations. GE had resources Whittle could only dream of. Massive factories, unlimited funding, thousands of engineers. They took Whittle's design, reverse-engineered it, and within months had produced their own version, designated the IA. On October 2, 1942, less than a year after receiving Whittle's engine, the Bell XP-59A era Comet took off from Muroc Dry Lake in California. It was America's first jet aircraft, powered by two General Electric IA engines. Whittle had spent over a decade begging for support in Britain. The Americans went from zero to a flying jet in under 12 months. And here's the remarkable part. Whittle helped them do it. In 1942, he traveled to the United States personally to assist General Electric with their development program. He spent weeks with their engineers, answering questions, solving problems, sharing insights that had taken him years to figure out. His son Ian later recalled that the Americans were astonished at how quickly they'd managed to get a working engine. And Whittle, despite everything his own country had done to him, was impressed by their enthusiasm. They weren't dismissing him. They weren't telling him it was impossible. They were listening, learning, building. General Electric didn't stop with one engine. They refined the design, scaled it up, created an entire family of jet engines based on Whittle's work. The J-33, the J-47, engines that would power American fighters and bombers for decades. By the early 1950s, GE was producing thousands of jet engines a year, selling them to military and commercial customers around the world. The company built an empire on technology they'd received for free from Britain. And what did Whittle get? In May 1948, the British government established a royal commission to determine appropriate compensation for Whittle's contributions to jet propulsion. They deliberated for months, weighing his achievements against what they felt the nation could afford. Their final decision was £100,000. Tax-free, granted, but still, £100,000 for inventing an industry that would be worth trillions. By that point, General Electric's jet engine division was already generating tens of millions of dollars in revenue annually. Rolls-Royce, using Whittle's designs, was doing the same in Britain. Boeing, Lockheed, Douglas, they were all designing aircraft around jet engines that existed because of Whittle's vision, and he received a one-time payment that wouldn't even buy a small factory. He was also granted a knighthood, became Sir Frank Whittle, Knight Commander of the Order of the British Empire. The honors looked good on paper, but titles don't pay the bills, and recognition doesn't undo 15 years of rejection and betrayal. Whittle accepted the knighthood, collected his £100,000, and quietly retired from the Royal Air Force in 1948 on medical grounds. He was just 41 years old, and his career in aviation was over. For the next few decades, Whittle lived in Britain, working as a consultant, occasionally lecturing, watching from the sidelines as the jet age he'd created transformed the world. But in 1977, he made a decision that said everything about how Britain had treated him. He emigrated to the United States. Not for a short-term position, not for a temporary project. He moved permanently, accepted a teaching role at the United States Naval Academy in Annapolis, Maryland, and spent his final years educating American engineers. The country that had invented the jet engine lost its inventor. The country that had taken his technology for free became his home. Every commercial aircraft in the sky today, every Boeing, every Airbus, every jet that crosses an ocean or shuttles passengers between cities is powered by descendants of Frank Whittle's engine. The turbofan, the turbojet, the turboprop, they all trace their lineage back to that screaming prototype he tested in Rugby in 1937. Rolls-Royce builds engines worth billions using principles Whittle established. General Electric does the same. Pratt & Whitney, Safran, CFM International. Every major aerospace company in the world stands on foundations he laid. The numbers are staggering. Over 100,000 commercial flights operate every single day. Millions of passengers. Billions of pounds of cargo. An entire global economy built on the back of technology one man invented in his 20s, while the experts told him it would never work. The jet engine didn't just change aviation, it changed everything. It shrank the world, made international travel accessible, turned overnight shipping into routine business. Whittle's invention is as fundamental to modern life as the internet or the transistor. But Frank Whittle never saw the full scale of what he'd created. On August 9, 1996, Sir Frank Whittle passed away in Columbia, Maryland. Not in Britain, not in Coventry, where he was born, not in Cranwell, where he'd first conceived the jet engine. He spent his final years in America, the country that had embraced his technology with the enthusiasm his own homeland never showed. He was 89 years old, and he had outlived most of the people who'd dismissed him, rejected him, and stolen from him. His remains were returned to Britain and laid to rest at RAF Cranwell, the place where it all began. There's a kind of poetry in that, a full circle. The young cadet who'd dreamed of flying higher and faster than anyone thought possible, who'd scribbled equations in notebooks and imagined engines that didn't exist, finally came home to where that dream was born. Coventry, his birthplace, erected a memorial. The Whittle Arch stands in the city center, a striking white structure that frames the sky. Tourists walk under it every day, most of them unaware of the story behind the name. Beneath the arch sits a statue of Whittle, cast in bronze, seated with a model of his jet engine in his hands. It was unveiled in 1998, 2 years after he passed away. He never saw it. The city that produced him only honored him after he was gone. There are other memorials scattered across Britain. A plaque at the British Thomson Houston Works in Rugby, where he ran his first terrifying test. A display at the Royal Air Force Museum in Hendon. His name appears in textbooks, engineering courses, aviation histories. But these are footnotes, gestures. They don't change the fact that Britain failed him when he needed them most. Perhaps the most remarkable part of Whittle's legacy isn't the technology or the memorials. It's what happened in 1991, 5 years before he passed away, when he and Hans von Ohain were jointly awarded the Charles Stark Draper Prize, one of engineering's highest honors. The two men who'd raced each other to build the jet engine, who'd been on opposite sides of the most destructive war in history, stood together on stage and accepted the award as co-inventors. They had become friends, close friends. They corresponded regularly, visited each other, spoke at conferences together. The rivalry was long over. What remained was mutual respect between two men who understood what it took to turn an impossible idea into reality. Von Ohain said something about Whittle during one of those later meetings that cut straight to the heart of this story. If I had to go through what he went through, I would never have finished the jet engine. Think about what that means. Von Ohain had everything. Unlimited funding from Heinkel, support from the German government, a team of skilled engineers, access to the best materials and facilities. And even he admitted that if he'd faced the obstacles Whittle faced, the rejection, the poverty, the bureaucratic sabotage, he wouldn't have been able to continue. But Whittle did continue. For 15 years, he fought against a system designed to crush people like him. And he won, in the only way that mattered. His invention worked. It changed the world, and no amount of government incompetence, corporate greed, or bureaucratic blindness could erase that. So here's the question we should all be asking. How many Frank Whittles has Britain lost because bureaucrats couldn't see past their own procedures? How many brilliant ideas have been dismissed by committees who valued caution over vision? How many inventions that could have defined the future died in patent offices because no one could afford £5 to protect them. The jet engine exists because one man refused to accept no for an answer. But how many others gave up? How many walked away when the doors slammed shut? When the funding dried up? When the experts said it couldn't be done? We'll never know. And that's the tragedy. Frank Whittle gave everything to his country. His time, his health, his sanity, his genius, and his country gave him almost nothing in return. A knighthood, £100,000, memorials built after he was gone. But his legacy endures anyway. Every time you board a plane, every time you hear the roar of jet engines, you're experiencing the work of a man who refused to give up, even when his own nation tried to break him. That's the real story of the jet engine. Not a story of triumph, but a warning about what happens when nations fail to recognize brilliance until it's too late. Whittle invented the future. Britain let it slip through their fingers, and the world moved on without them.